in this problem, we need to show which is D-ribose, how it would look in a Haworth projection, and we specifically need to show ribopyranose. So we are going to draw ribopyranose, meaning that we need to make a 6-membered cycle. So that means that if I have a base, to abstract that proton from an OH group, this OH group will be attached to carbon number 5 because I need to have 5 carbons and 1 oxygen as a result, right? So I'm going to have the following kind of chemical transformation to form a cyclic structure. So Haworth projection means that I have my oxygen in a cycle, and those carbons are kind of towards me, right? Don't forget that. So I'm trying to make those wedges here shown, but that's not necessary. It's kind of understandable when you are drawing in a Haworth projection. That's just to kind of highlight this point. Numbering of carbons would be clockwise. So this would be our carbon number 1, 2, 3, 4, 5, right? So carbon number 1 is our anomeric carbon, right? And that is part of hemiacetal group. Okay, so since we are creating new chirality center, it can be either, actually we need to draw beta, D-ribopyranose, right? So we will leave that OH group that would be formed from the aldehyde group as last one, because we need to see how to position this beta one. So carbon number 2 has OH group to the right in the Fischer projection. That means that it will be down in the Haworth projection. And actually all these OH groups are down, so we are just drawing it like that, right? And carbon number 5 is not a chirality center, so it's OH group, this one. This oxygen is part of the ring now. How to determine where we should position our OH group that is from that oxygen? Remember, to assign alpha or beta for anomers, we need to compare the absolute configuration of the anomeric carbon and the last chirality center. And in this particular case, the last chirality center will be carbon number 4. And so that makes our life even easier than usual, right? So we see that OH group at carbon number 4 at the last chirality center is down. For us to make beta anomer, we need to show OH group at the anomeric carbon up, because those two carbons will need to have opposite absolute configurations.